Now, today topic is continuity equation. Continuity equation. Here, continuity equation is a basic. First point is the continuity equation describes a basic concepts. Continuity equation describes the basic concepts. That is basic concept means a change in charge carrier density, a change in carrier density over time is due to the difference between the incoming and outgoing incoming and outgoing flux of carriers plus flux of carriers plus the generation and minus the recombination the flow of carriers. Next point is the flow of carriers and recombination and generation rates as shown in figure. First, draw the diagram. Is represented the electron current and positive is generation process, negative is recombination process. This is Jn x. This is Jn x plus dx. Jn x Jn x plus dx. Here, this is the x. This one is the x. This one is the x plus dx. This is EC. This one is EV. This one is R N. This one is GN. RN GN. Figure is electron current and possible recombination and generation process. Next point, the rate of change of carriers. The rate of change of the carriers between x and x plus dx. X and x plus dx is equals the difference between the incoming flux and the and the outgoing flux, outgoing flux plus the generation and minus the recombination. Minus the recombination. Write the formula for this concept. Dou n x comma t divided by dou t capital A dx, that equal to jn x by minus q minus jn x plus dx divided by minus q into capital A plus gn x comma t close brackets minus rn x comma t equal to a dx Here n x comma t is carrier density, carrier density, comma capital A is the area of this cube, and capital Gn is generation rate, generation rate Next, Rx comma T. Next, Gn x comma T is generation rate, and Rn x comma T x comma t is recombination rate. Recombination rate. Recombination rate. Here, by using Taylor series, this equation is by using Taylor series. Taylor series expansion. Taylor series expansion. That is, equation is Jn x comma dx equal to Jn x plus d Jn x divided by dx into dx. By using Taylor series expansion, write the equation, this type of equation. Next, this equation can be formulated as a function of derivative of the current, as a function of derivative current, derivative of the current, derivative of the current of electrons. That is dou n x comma t divided by dou t, that equal to 1 by q dou Jn x comma t divided by dou x plus Gn x comma t minus Rn x comma t. Next, similarly, the equation can be formulated by the derivation of current in holes. Similarly, for holes, that equal to dou p x comma t divided by dou t, that equal to minus 1 by q dou jp x comma t divided by dou x plus gn x comma t minus rn x comma t. Once explain that this concept is continuity equation. Here the continuity equation describes a basic concepts in semiconductors. That means the change in carrier density over time is due to the difference between the incoming and outgoing flux of carriers. Plus is the generation, minus is the recombination. See the diagram. This is One is the cubic box. This diagram is represent the electron current and possible recombination and regeneration process. This is the incoming of current densities. This is the outcoming of current densities. Here two energy bands is there. This is the EV is the conduction band, EC is the EV is the valency band, EC is the conduction band. Here in the valency band some electrons is there. We are applying the energy. These electrons are absorb this energy and excited to the higher energy state. That is the EC. That is the conduction band states. Here in this position hole is created. After some time this electron is de-excited from conduction band to the valency band. That is de-excitation or recombination with holes. That is recombine the holes, that means electrons. Next point is the flow of carriers and recombination and generation rates as shown in figure. This is the generation of electrons. This one is the recombination of electrons. Here the rate of change of the carriers between the x and x plus ds is equal to the between the incoming flux and outgoing flux. This plus is generation, minus is recombination. Write the equation dou n x comma t by dt equal to a dx, that equal to jn x by minus q minus jn x plus dx by minus q into a plus gn x comma t minus rn x comma t into a dx. In this equation n x comma t is the carrier density. Here a capital A is the area of the cube, gn is the generation rate of charge carriers, Rn is the recombination rate of charge carriers. By using the Taylor series, according to this equation, write this Jn x plus dx equal to Jn x plus j d Jn x by dx into dx. Here, next, this equation can be formulated as a function of derivative of the current for electrons. Current for electrons, that equal to, according to this equation, this is equation 1, this one is equation 2, this one is equation 3, this one is equation 4. Equation 4, that equal to, here from the electron dou n x comma t by dou t, a dx, a are cancel, that equal to electron density is equal to here jn x by minus q minus jn x by minus q minus jn dx by minus q. Here jn x by minus q minus jn x by minus q both are cancelled. Here in this equation dx means, therefore dx means dou by dou x, x comma t dou by dou x, dou by dou x, that equal to, according to electron equal to dou n x comma t dou t equal to minus 1 by electron charge is minus 2, that equal minus minus is plus 1 by q dou jn x comma t by dou x plus gn x comma t minus rn x comma t. This is the equation 3. Next, similarly for holes, that is dou p x comma t divided by dou t, that equal to whole charge carrier is plus, that equal to minus plus minus 1 by q dou jp x comma t by dou x plus gn x comma t minus rn x comma t. Next, Next, the solutions of above equations can be obtained by substituting the expression for the electron and hole current. The above solutions of the equation by substituting the expression for the electron and hole current. Electron and hole current. These two partial differential equations. Two partial differential partial equation as a function of electron density, as a function of electron density, the hole density and the electric field, the hole density and the electric field. The electric field itself from the Gauss law, according to Gauss law of the electric field, that is dou n x comma t by dou t that equal to mu n dou sigma x comma t divided by dou x plus mu n epsilon dou n x comma t divided by dou x plus dn dou square n x comma t divided by dou x square plus gn x comma t minus Rn x comma t. According to Gauss law, the electron current density is this equation. Next, the hole current density for according to Gauss law, that is dou p x comma t divided by dou t, that equal to mu p epsilon dou p x comma t divided by dou x plus mu p epsilon p epsilon dou p x comma t divided by dou x plus dp dou square p x comma t divided by dou x square plus gp x comma t minus rp x comma t. This is the current density for according to Gauss law in electric field. Next, write a generalization in three-dimensional yield. A generalization a generalization in three-dimensional yield. Three-dimensional yields. The following equations of write the continuity equation for electron and hole. Electron and hole. That is dou n x comma y comma z comma t divided by dou t, that equal to 1 by q delta bar jn bar comma x comma y comma z comma t plus gn x comma y comma z comma t minus rn x comma y comma z comma t. Next, for electron hole dou p x comma y comma z comma t divided by dou t, that equal to minus 1 by q del bar jp bar x comma y comma t plus gp x comma y comma z comma t minus rn x comma y comma z comma t. This equation is represent the according to Gauss law for electric field. in current density of electron, that is equal to 3-dimension yield equation. Dou n x comma y comma z comma t by dou t, that is equal to 1 by q del bar jn bar x comma y comma z comma t plus gn x comma y comma z comma t minus rn x comma y comma z comma t. Next, this equation is represented according to Gauss law of 3-dimensional whole equation. Dou p x comma y comma z comma t by dou t is equal to minus 1 by q del bar jp bar x comma y comma z comma t plus gp x comma y comma z comma t minus rn x comma y comma z comma t. This is the final solutions of continuity equation of 3-dimensional yield.